Rick. Appreciate it.
Perfect.
Yeah, so I'm going to, for those that, I know everyone's probably heard of the pilot, or most everyone, but I'm going to give, we'll give a little bit of background on what we're doing for the pilot. Then we'll talk about some of the challenges, and I've seen Bob Roush posting some information about challenges as well, so we commiserate about those. And then I'll give you a little bit of perspective on platooning itself, and what I think is some of the benefits and challenges of that. So, so the Tampa-Hillsborough Expressway, or THIA CV pilot, is located in the downtown area in 1 square mile. What you see here in front of you are the different applications that we're running as part of the pilot. These 11 applications make up 6 use cases. Most of our 3 of our use cases actually intersect. If you look there at the wrong way entry prevention there, you'll see that we have 3 use cases intersecting there. One is our morning backups we call rush hour collision avoidance. We have some apps there. We use V2V apps in terms of forward collision warning and emergency electronic brake light warning. We also have a app we developed, as you see the purple curve up there, that's called into-ramp deceleration, which gives speed advisories to folks as they're approaching the back of the queue of the reversible express lane there. THIA operates this reversible express lane, and so in the morning you have about 8,000 people coming in, and so that queue can actually back up to about a mile or so, and we just try to provide some guidance to people of, hey, you're coming up on the queue, so you need to slow down, and just give them an advisory speed. The wrong way detection entry is another use case. What we do there is people will actually turn into the expressway going the wrong way. We witness it almost every time we're there. So what we do is we're using some traditional ITS devices to help us with that. So we have a radar that detects the entry, but we're also using the map and SPAT for the vehicles. So as the vehicle actually turns into the expressway the wrong way, it would be turning into revocable lanes. So these lanes would be revoked. It's a bit in the map itself. And so that as they turn in there, they realize they're going the wrong way, the OBU does. And so the app warns the driver that, hey, you're entering the wrong way area. And then if they continue up, we use the radar to say, hey, you're really going the wrong way now. Another app we have is this pedestrian safety at the courthouse. We have, especially on Mondays and Tuesdays, you have 400 or 500 people going to jury duty into an unsignalized crosswalk from a parking garage on one side to the courthouse on the other. We're using LiDAR to track pedestrian movements. Each one of the pedestrian movements is then turned into a personal safety message that's sent to our RSU that's mounted there, and then that broadcasts the PSM out. And the vehicles that are approaching that receive those PSMs and then do basically a collision avoidance, kind of think of it as an intersection movement assist, where it determines if the pedestrian in the car has a potential collision, and it warns the driver that they need to brake or stop. The blue areas is basically our transit signal priority corridor. So we're doing transit signal priority through there. As the bus approaches the intersection, it's always requesting priority. The RSU receives that, contacts the central office, the transit facility, and determines if the bus is behind schedule. If it's behind schedule, we grant priority. What that means is if the light's green, we extend it. If the light's red, we just ask it to cycle through the light as fast as possible. We don't ask the controller, don't tell the controller to preempt. That's totally different. If the bus is not behind schedule, then nothing happens and the driver just continues on. We're also doing stuff with streetcars. As you see along the green area there, we have about these 40,000-pound historic streetcars made out of metal that run on rail, just like regular railroad track, and people will actually not see them and turn right in front of them. So we're using the app Vehicle Turning Right in Front of Transit Vehicle to not only warn the streetcar driver of a potential collision, but also the driver of the car that they're about to hit a street car. And then we have what we're calling traffic management or traffic progression. That's the blue area coming down from top to bottom. What we're doing there is we're using the University of Arizona Larry Head's MIT software to do some ability to do some, if you will, green wave, or we look at queues and we try to move queues of cars through that corridor without having them to really slow down. So we, just to give you a status, we are all complete with phase 2. In fact, we're halfway, we're 2/3 of the way through phase 3 now, the data gathering phase. There's a lot of data that's been gathered. If you go out to the ITS Public Data Hub, you can find a lot of data from the Tampa pilot as well as the Wyoming pilot to see what we've been doing. And so what we're finishing up here is in February, at the end of February 2020, we finished collecting our data, and then in February we'll finalize our data stuff, and then in May of 2020 the pilot will complete. So we're on our last legs that we're headed at. So now let's talk about some of the challenges we had, and these are obviously specific to the Tampa pilot. We recruited private participants or private vehicles. So everyday people who drive the reversible express lane, what they did was they offered a toll incentive for them to sign up for it. And we had initially over 3,000 people say they were interested. We had many of those people signed up, and then we had some delays for a variety of reasons, and we ended up losing almost 75% of those folks. Today we have about 900 deployed, and our goal was 1,600. So we did peak out at almost 1,100, but for a variety of reasons, either people moving out of the area, they didn't want to participate anymore, or whatever, we've had a drop off in that. The installations, if you're going to do a large installation, my recommendation is you find somebody and you make it their responsibility. Essentially, you start running a used car service, if you will, where people are coming in, they're calling in for problems, they're constantly having issues, or they don't know how to use the equipment or whatever, and it just becomes a nightmare. So, you know, as agencies, as IOOs, you know, you really won't be in that business of that long term, but as you try to help get things deployed and deploy things in fleets and do some connected fleets, then we're going to have to deal with that. So my challenge is, or my recommendation is, to very carefully plan your installs. Security, I want to spend a little bit of time on this, the security credential management system. Ultimately what happened is all 3 pilots are using a private SCMS. To me, this is one of the critical pieces for anybody that's going to be doing a connected fleet challenge. I assume that all the SPAT challenges are running without security, without any certificates to their messages, which is fine for now. But we're getting into a real world deployment, and people need to start thinking about building an SCMS, or not building, but getting access to an SCMS so that they can transmit and receive their messages securely, especially if you're exchanging messages between vehicles, for example. You don't want anybody to hack those. So SCMS and security are going to be a really big problem, or big deal to complete. Ensuring you solve real-world problems, that's just as part of the pilots, kind of a THEA's mantra. They don't just go out and say, hey, we're going to deploy these apps to do that. They did some research up front and said, hey, what are the real problems out there? And then they generated their use cases around that. This one, the penetration rate of connected vehicle, as you can tell, you know, I think Blaine put up there would be about 9,000 OVUs on the road. So it's very low penetration rate. So as I've described a couple of times, we've augmented our ability to quote unquote identify vehicle location stuff using traditional ITS like radar and cameras to help us build the data for the apps that we're using. So as the penetration rate goes up, then the need for the traditional ITS will go down, but in your current deployments, I think that would be a very important consideration for you. And I think this was already kind of talked about, but the apps, you know, when we started the pilots, we were under the belief that the apps were really there and mostly ready to go, and we found out pretty well about 6 months in that really wasn't the case. And as I think Curtis said, that the vendors, they're not hardware, they weren't ready. We were pretty amazed at a lot of the issues that they've had. And I will just, you know, I'll make this statement. The devices we have are not automotive grade ready. We've had issues with vibration and things like that where the OBUs will fail or something that have to be replaced. So just know, as you talk to these vendors, you need to make sure you push on them to provide you quality product that they probably can't provide automotive grade, but they need to know. You need to know what you're getting going in. You know, do your homework early to have a successful deployment. Don't just say, hey, we think we want to do X, Y, and Z, and then try to figure out how to do it. But do your homework early, get everything mapped out, get your vendors mapped out, and take care of everything. Pedestrian detection was just, when I talked about that app, we ended up using LiDAR. We initially tried to use, we thought about trying cell phones, knowing the GPS was an issue. But we thought we would try that. But we also found out the wireless connection the phone had to make to the RSU was a challenge as well because of the number of wireless networks running around there and just being able to have a solid connection back to the RSU to transmit data. Tampa is the lightning capital of the world. So our RSUs, even though they grounded them, it turns out some of the mast poles and things they grounded them to had been there for 30, 40 years. Found a rusted bolt that allowed it to, when the lightning struck it, it blew out the RSU. We found powder coating that caused between two parts of the mast arm that didn't allow it to ground properly. So there's a lot of issues or concerns you need to look at when you go to mount something up on one of your poles. Just make sure that everything you need in terms of grounding is there. Because what happened to us is that the lightning would strike and it would go right into the RSU. And it would find the PoE connector and just fry the RSU. Communication infrastructure, really what that is talking about is more of make sure you have the best backhaul you can from your RSUs back to wherever you're pulling the information. So back to your traffic management centers or such. Thea is using a lot of city intersections, and they don't have fiber in place, so we ended up having to use Verizon LTE to backhaul our data across that. So you can imagine 35 or 40 intersections pumping data back and forth, how much that might cost. So just know that, be ready for that or plan for that. Again, if you've got fiber, that's obviously the best way to go. Over-the-air updates are critical. We are doing over-the-air updates to download and or to upload, however you want to say it, to the OBUs to update the firmware as well as the configuration files. And then we're also pulling these data logs off the OBUs back to the RSU and sending that data all the way back over to our performance measures guys. That's the data that's really being analyzed. In a real-life deployment, you really won't have that data. You won't be pulling these logs, so that's maybe not as big a challenge long-term, but for this pilot, it would be something you want to consider doing. Obviously, we have two vendors that have got that. New York has one, and Wyoming has one, so there are vendors that know how to do it. And I would just encourage you guys, as you're thinking about it, what data do you want and what data do you need and how are you going to evaluate success, then you really want to think about that. The other thing that we really kind of learned was that is to get some infrastructure out early and try to get the vendors, the OBU vendors out there to just do some system to end-to-end testing. There's nothing like being in the real environment. Just a perfect example of that was we were doing a big test for USDOT, and all our applications just quit working. And it turned out there was we were getting interference from a ham-wham radio operator on one of our channels, and he was just broadcasting over all our messages, and so we couldn't get anything out. So you just want to make sure you're not only is your infrastructure ready, but everything is ready, that you've got clear airways and you can operate. And then one of the challenges we have with our OBU vendors in particular, but our RSU vendor as well, is that they have distributed teams, and so some are in Europe and some are in India. So being able to get quick response or information is sometimes difficult. You might think it's great, they can work on the problem overnight and have a new solution, but it doesn't always work that way. So just know when you look at your vendors and talk to them, I would ask them, where's your development team, what's your response time, and those kind of things. Finally, I just want to wrap it up with truck platooning. So we had, these are some challenges I see with truck platooning. I was actually part of a truck platooning workshop in DC a couple of months ago with Ken Leonard and Steve, I can't remember his last name, CEO of Peloton. But we were talking about truck platooning, and so I just wanted to throw this up here and say, what kind of platooning issues do you see? Well, there's, if you've got a platoon of trucks or vehicles or whatever, getting on and off the freeway, for example, something that I'm not a traffic or a roadway guy, but there's, when you have vehicles following very close to each other, you get a lot of wear and tear on that same lane. You can have issues with bridge weights if you get too many, especially trucks on there at the same time. And then what do you do about the people who decide that, they want to cut in between two trucks in the platoon? So just some challenges to think about. But the benefits are, you can move freight much more efficiently. Obviously, you can get improved energy efficiently because you get a lot better, the word escapes me now, but they get a lot of they're close enough where they improve the black ones improve gas mileage. You can reduce costs, and then you get improved safety. And as many of you know, in trucks especially, we have a huge driver shortage right now. So automated vehicles or vehicle trucks is probably a good thing. And that's all I have, Patrick.